Hello and welcome to another episode of Whither the Looniversity, the podcast of the Peerless Review. I need to give a warning to our listeners and viewers today that I will be demonstrating my innumeracy today. Statistics, freshman statistics, was the only course that I received an F in college, and now I'm going to attempt to do some serious statistics talk with my guest today, who is Dr. Ryan Martin, professor of statistics at North Carolina State University. He is author or co-author of nearly 100 scholarly papers now. He's got two books in addition to his forthcoming Fundamentals of Statistical Inference. He's the winner of multiple grants, including many from the National Science Foundation. And he's a personal friend because he is one of the co-founders of Researchers.One, which is an online platform for scholarly publication. You can find it at Researchers.One. Professor Ryan Martin, welcome. Thanks for joining us.
Yeah, thanks so much, Adam. Great to be here. Yeah, thanks.
So, I just mentioned that I failed my statistics course, and it was part of that was because I'm not a math person. Part of that was because it was at 8 a.m. And I was 19 or 18. But this is, to me, a masochistic field. Explain to me how someone gets into this. How did you, as a kid, right? But prior to going to the university, were these things that interested you, and what guided you towards, say, statistics instead of mathematics as you did hit the university?
Sure. So I guess, by the way, I should say that my first statistics course, I guess like you, I didn't get an F, but I did get a C. It was in an econ statistics course, and it was pretty awful. And so I couldn't get it. And so something like a C grade, one of the worst grades I've ever had in school, was in a statistics course. So you're not alone, I guess, in that kind of experience. But so I guess how did I get into this? Well, I guess when I was younger, I played baseball. And so, of course, baseball has lots of statistics attached. And so you kind of get used to seeing these numbers as kind of representative of some kind of I guess, performance of players, or I guess a kind of likelihood of one kind of outcome, team versus another team type of ideas. So then, I guess it wasn't so surprising that, kind of this ended up being a direction that I would go, but it wasn't sort of directly. So when I was in high school, I guess I was interested in science and math. And then finally, when I went to college, I started as an engineering major. And then it ended up that, well, I didn't so much like the engineering aspect of it. I only really liked the math. And so then after some years of kind of hearing people talk about car engines and things that weren't interesting to me, I eventually switched over and just said, okay, I'm just going to major in math. And so then, of course, by the time you get closer to your time to graduate, you're like, what the hell am I going to do with a math degree? And so around sort of towards the end of my time in college, I took a stats course, and this was like a stats course that was taught to from kind of like a mathematical angle. And then I started to see that actually some of the common sense that I had from baseball and statistics kind of showing up in the math. That, so as what you kind of develop some more mathematical techniques in the statistics course, and you see, okay, there's actually some justification for why do we measure performance of a hitter using a batting average, right? There is it's not just because it's intuitively the right thing, but actually there's some mathematical justification for this. And so this, I don't know, this kind of a linking of the math that I enjoyed and some of the common sense that I had from in baseball, I guess. That I found that to be kind of an inspiration. And so I thought, okay, well, this maybe is the right kind of path for me, is to maybe get some more education in statistics. And, I guess at no point until it actually happened did I expect to be a professor of statistics, but I just kept going to school because that seemed like the right thing to do. And then eventually I never left, I guess.
That's similar to my story. You get so far into at one point where you're like, well, I guess I got to go all the way now.
Yeah. It was like all I really know how to do is go to school. So I
Yes.
guess.
Yeah. That's what I often tell people. I have no marketable skills outside of the very narrow little thing that I do
Yeah.
as a
Yeah.
professor. So let me ask you this. That's actually interesting, that baseball connection, in part because your friend Harry Crane, who you do Researchers.One with,
Yeah.
is a gambler who is interested in sports betting and the application of statistical reasoning in that direction. Um, can you explain, just for me and maybe people who are listening, this seems, I'm sure, like an elementary question, but if you were talking to an idiot, how would you differentiate statistics from mathematics?
Uh, well, so there, I mean, definitely there's mathematics that are involved in statistics. I guess one thing that's a key difference is that so in math, I mean, and I guess you can get really sort of really deep into this and then you start to really question everything. But in math, there's I guess some rules that are like almost everyone agrees on. This is how you reason mathematically, and you say, okay, from these basic kind of principles, you can reach certain conclusions, and then the calculations that you get or the deductions that you make, these are sort of logically valid because you followed all the rules. Statistics is a little bit different because you can end up having situations where like your line of reasoning is all solid, but the conclusion is wrong because there were some inputs that you were given that are out of your control, but those things tend to happen to be misleading. So it's like because you're basically at the mercy of the data that you have collected, and so these data can have certain aspects that wouldn't have been anticipated, and these
So,
are
for
kind of like things
example,
they
if
call like outliers, right? So there can be outliers in data. You have no control over this, and so those can actually point you to conclusions that turn out to be wrong, even if your sort of line of reasoning based on it is correct. So that's one of the differences, I guess, between math and statistics, is that in math, if you follow the steps correctly, you get to the sort of the right answer, whereas in statistics, you can do all the things basically right and still end up wrong, and in many cases you don't even know whether you were right or wrong because like truth is never revealed.
Is it safe to say then that in a sense the statistics is the application of mathematics to real world phenomena, that the purpose of the mathematical calculation that you're doing isn't just to work within the system of math itself, it's to set to essentially it's predictive about the world. Is that accurate?
Yeah, I mean, so I guess I was kind of talking about these different kind of lines of reasoning, and in math, there's kind of one direction, which is here are sort of axioms, and these lead to new conclusions, but ultimately those conclusions are contained in the information you already had because it's sort of determined by the axiom system. But in statistics, it's more like you're reasoning towards creating something new. So you start with you have some data, or yeah, I guess in this context, you'd have some kind of data, and you have maybe some kind of understanding of the scientific phenomenon that you're looking at, and you say, okay, based on data and some basic understanding, I'd like to reach some new conclusions, maybe some new theory that deserves some further investigation. So it's like this process is about kind of creating knowledge. You didn't have it before, and now you collected some data and you put some things together and you tried to create some knowledge, which is different from the mathematical one. So it's kind of like using some of these like mathematical tools and data and modeling techniques towards creating new knowledge.
Pretty fascinating. So your
Yeah, you
specialization.
maybe would have done better in the stats class if they told you like that versus here's how to calculate XYZ.
Yeah, maybe. Or like getting to class sometimes probably would have
Yeah,
helped
yeah,
too.
that doesn't hurt. Yeah.
Um, your the niche that you've carved out for yourself in statistics relates to statistical inference and probability. And this interests me in part because my area of expertise is rhetorical theory. Rhetoric, of course, is the art of persuasion, of convincing people. And Aristotle, in his treatise on rhetoric, one of the things that he tries to say is the value of rhetoric is that it can help us to navigate what he calls probabilistic truth, right? That that certain questions, there isn't a finite answer that we can determine, that all we can say is this is probably true. And it seems to me that what you are interested in is quantitative approaches to calculating and inferring probability, the likelihood that something's going to happen. And like you just said, sometimes your input, your data is wrong, and so that can lead you to an inaccurate inference. So my question to you would be, as you know, there are quantitative ways of inferring probability and qualitative ways of inferring probability. Like take informal logic. It seems to me, as I was reading over some of your scholarship, that there's a heavy kind of layover or overlap with logic, formal logic, in what you're doing. And so how is statistics and statistical inference a more reliable method of inferring probability than, say, just sort of intuitive, informal logic or sort of dialectical rhetorical reasoning? Does that question even make sense in your world?
I think so. So let me try, and you can
Okay.
stop me if I'm going off track. But so I mean, definitely you're right. Is that, you know, the idea here is that we want to have some kind of like a formal system that one can follow that says, okay, I have certain kind of inputs that I'm going to be presented with. So this would include data in, I guess, in almost all the cases. This would maybe include some information about the scientific problem or whatever problem you're investigating. So you might know something, you maybe have talked to some experts, you might be an expert yourself, right? There's things that you have to that are available somehow that you might want to use as part of your reasoning. You may have some, you know, in terms of, you know, how this can, you know, what I guess what I just said about this information you have available. This can be more intuitive. This can also be more like, I guess, in terms of like physical understanding. So like, you might have some kind of models that you can formulate that come from like the you know, physics or astronomy or something, depending on the context. Like there might be some information that you have available that you can help to kind of like formulate this problem in I guess a more rigorous kind of way. But then what you want, I mean, that's kind of pre-statistics inference. That's like, these are kind of like inputs, collecting data, formulating models. Then the statistical inference step is supposed to be about like, I have identified some kind of you know, unknowns that we seek to know something about. So these are the things that we want to infer. So often they're called model parameters or other kinds of like population parameters, things like this. And we want to like use the information in the data and these models to learn something about these parameters. And so we want to have some kind of a formal process about how do you convert that information that you have to start with into something that now is sort of representing kind of like the measures of, you know, truthfulness or falsity for claims that you might make about this unknown. So is the you know, things that happen, like I guess recently we were seeing stuff with like elections, right? So this is, I guess, a little bit different than the inference per se, but it's related. Is that you want to be able to say something about what's going to happen as the outcome, what's going to be the outcome of the election.
There's a red wave.
Yeah, right. So yeah, I mean, well, it's, I guess since you mentioned that, I mean, I guess it's funny that, because I see on the news the last couple of days, right? They're trying to dissect all of this now and kind of looking back and just sort of say what went wrong, right? With the, you know, because there were these predictions about the red wave, and then I guess in a sense it didn't happen, and so then they're trying to dissect this thing and to try to figure out all the stuff that kind of went wrong. But this is actually where you can kind of you know, reveal some of the things that they were assuming before that they didn't tell you about at the beginning when they make these predictions, because then now they have to, you know, come up with some excuses for why for why things didn't go the way they said. But anyway, I mean, that's kind of getting into maybe another aspect of this, is that of course there's some kind of like subjectivity to these inferences that we try to draw. We can try to make this as formal as possible, but it's not a kind of thing that can be done kind of independent of any sort of like subjective choices.
So let me ask then, what does a statistician do with the anomaly? right? When you've got this data set and you're confident in the data, that the data that's the input to make the predictive or the inference about what will happen, right? You're confident at the data that you're inputting on the front end, right? And then you get this weird result, right? Does a statistician just shrug his or her shoulders and say, well, sometimes weird things happen? Or then do you dig into the deeper into what happened and try and figure out, like, well, why didn't what we thought would happen? Or is there a point at which you just can't know? Like, sometimes the coin comes up 10 heads in a row and who knows why, it just does.
I mean, certainly there's some value in kind of doing like an autopsy of to kind of figure out what what killed an analysis, or maybe in I guess in success stories, maybe to figure out what exactly was the driving the success. But I think that a lot of it is to understand you it helps to know what maybe went wrong, so that next time you can, I guess, to attempt to try to avoid making these kind of mistakes. I tend to think that there's we often are maybe overconfident in our abilities to assess I guess assumptions that we can or can't justify. So this, what I heard them talking about with this, like the red wave kind of thing, I forget if it was today or yesterday, but that they of course have to do some, they can't take the exit polling data sort of as is. They know that there's some bias in the responses, that when they take samples, they get some responses. They know there's some bias in there that, like, for example, people maybe they don't feel like they don't want to admit being Republican or something like this. And so they'll tend to give answers that don't necessarily reflect the reality. And so then the people who do the analysis for these kind of data, and I guess I should say I'm not an expert in exactly how they do all of these things, but I understand basically how it works. And so they have to make some adjustments for this. And so they have to decide, well, how am I going to make an adjustment for this? And so these are things that they really don't know what to do. They can have some thoughts about maybe strategy A, B, C would be reasonable ways to approach this, but they don't really know. And so then they come back later and say, well, that choice we made about picking B instead of C turned out to be a bad one. But I think what this helps to do is to realize maybe like how how maybe how little we know, and so that maybe what we should be doing, and I don't know if they learned this lesson, but that we need to be more conservative, more cautious about the kinds of predictions that we make, especially in things like that where the maybe has some kind of like a practical consequence. So I mean, the elections obviously have a practical consequence, but the predictions one way or another maybe don't. It's kind of maybe partly kind of a game. It's that people like to play this game about being right at making these predictions, but things where there's more serious consequences, like about COVID, obviously, like COVID vaccines. So these are things where maybe there's more cautious or more caution is needed, and to understand that actually there's lots of things we don't know, and the choices that we make affect the outcome of the analysis. And
this again is where our fields overlap, though. I would say that there's a lot of stakes to sort of predictive statistical models about elections. I mean, if you run around for 3 months before an election saying, oh, it's going to be a red wave, oh, it's going to be a red wave, oh, it's going to be a red wave, that affects voting
that's true. Yeah,
patterns. It
that's true.
affects
Yeah.
and so in that sense, like and maybe this is a time to get into this question because we're kind of touching on it anyways. There's an enormous skepticism now in the United States about experts, expertise. And so often we are barraged with statistical data, especially around elections, but around COVID, around, like almost every real big concern of public policy has some statistical evidence in play. And I know, as anyone knows, right, there are bad statistics. But what would your advice be to normal people like me who don't really understand how various statistics are compiled? Should we harbor a skepticism towards statistics generally? How reliable is the sort of general statistical reasoning that we see in press releases, this kind of thing? Or is it just some of it's good, some of it's bad, and there's really no way of knowing from a layperson's point of view? What do you say?
Well, I mean, that's a very difficult question because whether the statistics is good or bad, I mean, I guess for the most part has nothing to do with actual calculations that are done. So it's never that the calculation that was done, like they did the calculation, got the wrong number. So that's never the issue. So the issue is always about like what are they assuming towards reaching that conclusion. And often, I mean, I guess this can happen where people are sort of intentionally trying to mislead people, but this can often happen just from I guess not anticipating certain alternative explanations or alternative kind of theories and things like this. So there's always going to be some kind of like a choices, subjective choices that have to be made in some kind of data analysis. And so often the people who are reporting the data analysis have an agenda. And so then, you always have to be sort of questioning, these kind of aspects. Is there something that like the person delivering this analysis, are they trying to convince you of something? And so I think that very often that's the case. And so it's right to be skeptical of these things. But I guess what I want to say is that I don't want that to sort of indicate that we can't trust like statistics. It's a difficult subject because there's, I mean, aside from like the technicalities, is that there's lots of nuance to doing certain kinds of analyses, and you can do, even with the same data set, you can do one analysis and another analysis and actually reach very different conclusions. And so what's really important is about I think the kind of being honest about, well, I mean, obviously in a press release, they can't list out all of these details about how the analysis went, but I think if you want people to trust, trust the science, or trust in statistics more specifically, there needs to be, I don't know, I feel like somehow it needs to be communicated that this is like somehow like the best attempt that we have based on the information that's available. And so this makes things, I mean, it's a complicated process because there's sort of teasing out information from the data and then also trying to balance this with like policy decisions and things like this. And so it's certainly not just about like doing the analysis and calculating some numbers and making sure those numbers are correctly calculated. That's actually the tiniest part of it. There's just a lot that goes into analyzing data like this, and so it's right to be skeptical about it for sure. But there is still some promise, and so it's not a hopeless endeavor. I don't believe.
And is your sense that most of the people who are sort of calculating the statistics related to these big contentious points of public policy, would you say that generally the people doing those calculations are trying to do it in the right spirit, that it's more the people who are reporting on statistics who are leveraging those numbers to certain purposes, rather than that the statisticians or whoever's calculating the numbers goes into it with a certain outcome that they're seeking to advance?
I mean, I'd like to think so. I know, I mean, at least from my point of view, I mean, if I was presented with some data analysis problem, I would want to do the very best that I can. And I would have to think that, anyone else that's in position kind of like mine, where they're sort of honest scientists, really want to do the best you can. It's easy to, I guess, get into a trap where it's like you kind of get some results that seem to be supporting the conclusion that maybe you have in mind, and so it's easy to be kind of biased like this. There's, I guess, a famous quote, I guess it's by Feynman, basically says that roughly says like to be a good scientist, you have to always think of ways that you can be wrong. And so try to test out all the possible alternative theories. And if you can enumerate all the alternative theories and say these, I can eliminate those, then the conclusion that you're making must be right. That's, I guess, roughly the idea. And so there's this kind of idea that you would have to be able to try out all these possible alternatives that maybe would lead to conclusions that are disagreeing with the ones that you maybe are, I don't know if they're necessarily trying to get to that conclusion, but maybe it's leaning that way, right? You do have to consider all these other alternatives, and if you can't rule those out, then it's can be difficult to justify one conclusion over another one. I guess so. It's like you want to try to be able to exhaust all the possible theories before you can really make some kind of like conclusion that this is the I guess the right conclusion based on this analysis.
So you just mentioned that there can be, say, two accounts taken of certain data, and different people looking at those data arrive at different conclusions in terms of probability or what we can infer from the data. And this kind of, I think, touches on your most recent project. You and I were communicating by email a little bit at the tail end of the summer. And one of the things you said, this is a quote that you wrote to me: the field of statistics is in terrible shape, no real identity, with no common goals driving towards progress. And it seems that your recent work is focusing on what you call two distinct schools of thought in statistics. And I could very well get these wrong now. So where I get them wrong, jump in and say, no, that's not right. But as you talk about it, there are two different approaches in general in statistics. There's the frequentist approach and the Bayesian approach. And if I remember in looking at your notes, and this is where I might get it wrong, the frequentist approach to statistics assumes what you call a refutationist philosophy. In other words, it sounds to me like the approach is, let's figure out how this could be wrong. So you kind of assume at the outset that there's an error somewhere, and that is a way kind of to advance the knowledge, is negating incorrect inference.
Yeah. So it's like also like a falsificationist type of process, is that you have theories and then you try to do experiments, and if the theory doesn't align with the experimental results, like in modulo some kind of errors, then that's sort of evidence against the theory, and so then you can revise, and it creates this kind of iterative process in this way. So that's falls in line with like frequentist type methods fall in line with like the scientific method from that you learn like in as a grade school. Yeah.
And so essentially in the frequentist model, you're attacking the theory, right? That we strengthen our confidence in the theory by watching it thwart our attacks, basically.
Right, exactly.
Okay. And then on the other side is the Bayesian, and you say that this is driven by a confirmational approach or philosophy. And if I understand what you mean here, it's that we try to show why the conclusions are right. Is that accurate?
Yeah, it's like you think of it as like accumulating evidence in favor, and that eventually that'll tip the scale, and the truth will sort of be the winner.
Eventually, the positive evidence is so overwhelming that we can't deny the conclusion, or we can't reasonably deny it.
Yeah.
Okay.
So that, like, I mean, I guess challenge with this obviously is you have to kind of know what the thing is first, and then you start piling the evidence on. It's maybe you have to kind of already have an idea of the theory and then pile evidence onto it, whereas the refutation can kind of is easier, doesn't have to actually formulate the whole story in advance. But yeah, anyways, yeah,
it's always easier to rip down than to build up, right?
Yeah.
Okay. So as you said, the problem here is that these two approaches can tackle the same problems and draw very different conclusions. And that I think you've quoted some people, and you've also written on the fact that in any other field, certainly any other field that touches on science and mathematical reasoning, this would be a big problem. That you would look and say, well, wait a second. There can't be two different answers to this question. One's got to be right, one's got to be wrong. So we've got to figure out a way to reconcile this, which of the two approaches is right. And you sort of say, well, everybody's kind of content to just live with the problem, right? And kind of look the other way. And it seems that you said that for the most part, advanced students in statistics, doctoral students in statistics, tend to just take the approach that their advisor has embraced, and that's their approach. But it seems like your work recently is an attempt to reconcile or to resolve this disparity. And so could you tell us a little more about that, maybe in the way that you're most able, that might make sense to
Sure,
guys like me?
sure. So I guess one part that's like a key difference, and it's a technical difference, but I think I can explain this without technicalities, is that in the frequentist framework, which is the kind of thing that you learned in or you were supposed to learn in your class that you got an F in, is about some procedures that you can follow to refute hypotheses or refute theories. And so there is a probability aspect to it, but it's not probabilistic reasoning where you calculate a probability of the hypothesis and then use that for making inferences. So this goes one way, it's related to probability, but not sort of in a probabilistic reasoning type of way. Whereas the Bayesian side tends to focus on the calculating probabilities on hypotheses, and that the idea being that the true hypothesis should get high probability, and that's how you can confirm the truth. So this is really where I guess the role that probability plays in the two theories is really where there's some confusion. And so, of course, probability theory is really fundamental to all of this kind of like inductive logic, but exactly how this shows up in these statistical frameworks is different. And so this is the thing that's never really been reconciled, like the role that probability has to play. So what I've been, I guess the idea that I've been thinking about recently has to do with, I guess, a different form of probability. So this is what's called imprecise probability. And I can give you an example about how this kind of works. And so simple kind of thing would be is if I told you that I had a bag and the bag has red, green, and blue marbles in it, right? And so if I were then to ask you, okay, if I'm going to reach into the bag and draw out a marble, what's the probability that this is green? Based on that information, you really can't calculate it, but what you'd probably do is say, well, I think that maybe there's equal number of all three types of marbles in the bag, and so then the probability would be 1/3, right? But so you had to make some assumption there that was that there's roughly the same number of marbles of each color in the bag.
There may only be one green.
That's right, right. So if without this extra information, you had to add something in to do that calculation. So you couldn't do the probability calculation with just the information that I gave you. You had to insert some extra kind of information or extra assumptions. So maybe I could tell you a little bit more. Maybe I say, well, there's at most half of the marbles in the bag are green, right? So with that information, you could still say, well, that's consistent with there still being 1/3, 1/3, 1/3 like proportions. Or you could be very optimistic and say, well, actually, maybe I'll think that actually, indeed, half of them are green. And so there you get two answers, right? If you decide that it's 1/3, 1/3, 1/3, you'd say probability is 1/3. If you interpret the information and say, well, I'm going to be very optimistic, the probability of getting a green ball is one half now, because if half of them are green, then you would say it's a half probability. So you see, you get different probabilities based on the
assumptions that I make about this in question.
Exactly. So what the imprecise probability says is that don't insert any extra information and any extra assumptions. You just take, but you can't accept a probability number as the answer. So the imprecise probability would say that in the latter example that I gave you that had up to half of the marbles are green. The answer that you would report as the probability of green would be anything between 0 and 1/2.
So X is less than 50%.
Yes. So you'd be making a more cautious conclusion because you aren't willing to insert these extra assumptions that you really can't justify based on the information that's available. So this is one of the kind of ways in which the difference between the two schools can be reconciled, because it turns out actually that this frequentist school is making some assumption, the Bayesian school is making some kind of assumption. Those are both very strong assumptions about the analogy is like about the structure of the bag. And what imprecise probability allows you to do is to kind of be in between those two extremes. But you become more cautious in the types of conclusions that you can make because you're acknowledging that you're not making these assumptions.
It sounds to me like there's more intellectual humility.
Exactly. Yeah. Yeah. So, but I think that this is what we need, right? This is related to that trust thing that you were talking about before, is that if there's two players, like let's use this election thing, since that's I guess is relatively simple, and I guess
Nate
modern
Silver
times
says
relevant.
Hillary's got
Yeah,
a 99% chance of
exactly.
winning.
And then, but then there's somebody else saying they got the same data, they're saying the same thing, equally confident, right? How am I, as a consumer of this type of information, supposed to make sense out of this? So obviously, like Nate Silver and the others are they're free to make whatever kind of predictions that they want. It's then becomes difficult for us to trust these things, because these are all these different experts reporting very different answers. Then when they're wrong, then they have excuses, right? I mean, so there's all kinds of things that just, it doesn't seem, it doesn't, I guess it's not really kosher somehow. It's like it's like they're cheating. And so there's no reason for us to really take any of these things seriously, or we should at least be skeptical about all of them. When it comes to matters, I mean, obviously these, again, like Nate Silver's free to do whatever he wants. He can predict however he wants. And, if he's wrong, or he's right. That's fine. But in, I guess, more impactful, or like directly impactful things, like about the, let's say, COVID vaccine, right? The story is always, we're sure about this, but they're doing the same thing about the bag of marbles, right? So they're saying, like, this is the way to, we're interpreting this kind of incomplete information this way, and we do a calculation. They say the vaccine is going to be effective, and then they say, trust us, right? And then later they revise the thing and they say, no, now trust us, right? It's like when they really didn't have enough information to be as precise as they were to start with. The answer what they should be reporting is that basically like an interval of things, right? It's effective, it's either not or up to some percent, probability effective, right? Not to, obviously there's lots of details that we're sort of glossing over here, but I think that this,
it sounds to me like you're saying, don't make the inference, right? The primary inference is on the front.
It can be, right? So if the data doesn't support making an inference, then you shouldn't, because the only way that you can do it is by inserting assumptions that you maybe can't justify, and then you have to make an excuse for it later. So I think that this idea of the imprecision that this theory allows you to have, I think this is really critical to the I guess being able to hopefully reach some kind of thing where folks can trust results coming out of scientific studies, and I guess specifically about statistical analyses.
And so this idea of imprecise probability, you think, could reconcile this divergence in approaches to statistics?
That's my current thing I'm pushing. So I'm really sort of all in on this imprecise probability now. So I'm teaching a course now in this. It's, and all the lectures and everything is online. So if anybody's interested in checking this out, of course, would be welcome to. You can find the website from my website. You can find the link to the course. So anyway, so
how old is this idea? How old is the idea of imprecise probability?
It's interesting is that in the very old days, like origins of even the classical probability. So I think like maybe the first time this sort of showed up was George Boole. So this was like in 19th century sometime. But at that time they weren't sort of biased towards, well, we need to have like precise like numerical answers for these things. And so I think that they were more honest about, here is sort of roughly what we can imagine being able to do in a real life problem. Eventually this kind of got mathematized, and then it kind of loses some of this like I guess the connection to real world. And so the current theory of probability is basically from the early 1900s. That is, I guess, what we teach all the students. But this notions of imprecise probability started way back, and they didn't really turn sort of formal theories until like 1950s, 1960s. But this is something that's not known really at all in statistics. Folks in computer science have some background in these things, but this really hasn't been popular in statistics. And so I guess I'm sort of out there on a limb now, but I find this to be very promising. And so I think that I'm hopeful that this will be what's needed to kind of do this reconciliation.
So let me do what I'm really good at and throw a wet blanket on this real quick. you've written in your course notes about the inferiority complex of the field of statistics. My field has an inferiority complex too, but that's a separate thing. It seems to me that at least the public's perception of the value of statistics as a field of inquiry is its predictive power, right? And at least rhetorically, the way that y'all signal this predictive prowess is the precision of your prophecy, right? There's a 7.2% chance that this is going to happen. And it sounds to me like if the field at large sort of embraced imprecise probability as a form of detente to sort of chill everybody out, right? Get everybody on the same page. It may well be that the field would be more honest and more intellectually humble. But also you guys would more often be saying, well, it might happen. Right. And that sort of undermines that power of the predictive capacity. What do you have to say about that? I mean, I guess what I'm saying is that if everybody embraced imprecise probability, this may undermine the value of the study of statistics in the eyes of the public.
Yeah, I mean, I get what you're saying. I mean, there's certainly going to be cases where right now we're making sort of precise predictions about things, and if we were to be honest about, what we are assuming and whether we can justify those assumptions or not, then we might not be able to be so precise. And so, obviously, like, Nate Silver's not going to be famous by saying, just shrugging his shoulders and say, I don't know, right? He has to say something. But I guess I would argue is that the only conclusions that we can really justify are ones that would be confirmed by essentially all reasonable analyses that we could carry out, right? That's where the truth is, right? It's that if I could do one thing that's reasonable, it gives me one answer. I could do another thing that's reasonable, I get another answer. Another thing reasonable, get a different answer, right? All I'm seeing there is sort of noise in the choice of the method that I applied. The truth that, or whatever is contained in data must be somehow in the aggregate of all of those reasonable solutions I could have produced. So in a way, it's kind of like cheating to pick just one of those answers and say that one is the special one, and these other reasonable things that I could have done, those aren't the right answers, right? That's being, I think, overly confident. I haven't really thought about sort of how to formalize this, but I do think that this explanation of like what the data has to say about the problem is like the aggregate of all of the reasonable statistical methods that could have been applied to it.
That's interesting.
And that's what basically that's what imprecise probability would do, is that it would say all of these things that are reasonable give you an answer. Then imprecise probabilistic answer would be the interval of all of those reasonable answers. And so if the data is really so powerful that, or so informative that the choice of your statistical method doesn't matter, then the imprecise probability answer would also be precise.
Huh.
So it's like, this is like a check, right? So if I had lots of answers I could give and they all give about the same answer, then I know I'm right. And everyone should be confident and trust that conclusion. It's when there's this range of possible answers that's too wide, and that creates some kind of uncertainty. And so then it's where you maybe shouldn't be trusting those kind of conclusions.
It sounds to me too, like on the pro side, if more statisticians embraced imprecise probability, they'd have to apologize less, right? They'd be wrong less.
Exactly. Yeah. I think that's where that's where you can sort of earn trust, is by not being wrong. Maybe
you might
means
not
you can't
be exactly right, but you won't be wrong.
Exactly. Yeah.
That's
I mean, where you lose trust in people is when you say one thing and then have to apologize later and change. That looks bad, and so there's no way to know from one case to another. Is this going to be one where they have to change their mind and apologize later, or is this one that is it really right? Right. So I don't know which conclusions I should trust, and so therefore you trust none, and I don't think that's that's not healthy for society.
Well, we can't get much less healthy than we are now.
Yeah, we're already there. That's
Maybe this is a good chance or a good opportunity to turn to the university more generally. I ask everybody kind of to report on the encroachment of wokeness in their field, because I get to talk to people in a lot of different fields. And for a long time, it seemed people sort of operated under the assumption that left ideology couldn't permeate the sort of hard skin of STEM. Um, and I've heard from various people that it's that assumption, that inference may have been unjustified. And so, what do you see? Do you see this as a problem in statistics, or does statistics relatively remain unabused by these trends?
I mean, so statistics as a subject, I mean, maybe I'm uninformed, but I don't know. Statistics as a subject, I don't know, has been affected. I maybe would, if I thought a bit more about that, I would maybe change my answer. But in terms of like the education system, definitely there's effects. A thing that really troubles me is, there's of course a lot of push for diversity in hiring and also in like the student recruitment. And of course, I have obviously, I don't need to say this, but nothing against like whether we have a diverse student body. I think that that's actually healthy. But the problem is that you can't force it. So what ultimately happens, I've served on our admissions committee. I've served as chair of like the hiring committee for faculty. And so you make these sort of pushes for, well, we need to interview some diverse set of candidates, or we need to admit a diverse collection of students. And of course, I understand the mission, but what ultimately happens is that there's not the numbers to back that up. So in my department, so it's actually a very large statistics department. We have, I don't know, 400 student applications for like graduate program.
Wow.
And we, in our heyday, we were bringing like about 30 PhD students a year. It's down maybe to 20-ish now.
Very
And then
competitive.
many more like master's like students. I'm not sure what the number is, but I mean, we're admitting something in the area of 100 students per year. Based on my experience in these, in kind of evaluating these applications, I see, 10 are from like underrepresented groups. Now, I mean, just in terms of numbers, right, there's very little chance that like 10 out of 400, that those are going to be like the 10 that should, yeah, right. Yeah. And it has, I mean, obviously that has nothing to do with, any subset of 10, right? The chance that they're the ones that are the best ones, or, so it has nothing to do with being like the minority. It's just a numbers game.
Stats.
But, so what happens is that then there's still some, sort of forced into, I guess, giving students this consideration. And so again, there's nothing wrong with the consideration, but you ultimately then admit some of them. And again, it's not about their, admitting them. It's that you're putting them in a difficult situation because they're actually not, they maybe shouldn't have been admitted based on their background and like their training, not their like, social background. And so it's like, I always feel like we're taking advantage of those students to say, look, we have a diverse pool. It's at their expense because they end up having trouble. And so, we inevitably later have faculty meetings talking about in the, for like qualifying exams for a PhD program, ultimately these students tend to underperform. And then we're asking ourselves, are we not meeting those students' needs? And it looks bad because the number, proportion of ones who are struggling end up being, that proportion is higher of the minority students.
Right.
And so
you're in a difficult situation. You either let students fail out, which looks really bad.
Yeah.
In part because an admission is an implicit signaling that we think you could succeed here. Mm-hmm. Or you lower standards, right? Yeah. And make sure that everybody gets through, because we don't want to have the egg on our face when it shows that the people who didn't complete the degree are disproportionately belonging to
Exactly.
this group or
Exactly.
that.
Yeah. Yeah. Yeah.
It
And so
sounds to me like what you're saying is that you see it going in the latter direction, where the standards get lowered rather than endure the egg on the face.
yeah, or I mean, then you start to create some other kinds of basically like safety nets for the students, which is, like giving them some kind of like extra materials or extra like prep opportunities for like, I guess, filling in on some kind of missing background and stuff. But I don't know, I always feel like that looks bad too, because then if it's the only students participating in those things are in a minority group, then it's almost like it's a program for minority groups, and that also looks bad. And I don't think that that's the kind of message that you want to send sort of more broadly, that says like, look, here is a good place for a diverse group of students. If it looks on the outside, it's that, well, there's the usual group is doing their thing, and then we have this sort of safety net for the underrepresented groups. Like, that also looks bad. And I mean, ultimately, I feel like we're taking it, like I said, we're taking advantage of the students and sort of putting them in situations where it's not clear that they can be successful, just so that we can claim to be meeting some kind of like a diversity standards.
It's a moving
I'd
target
prefer
too.
to have the students go to a place that's going to be right for them, and that they can be successful, and they can ultimately, if they have a good experience in grad school, then they're a lot more likely to want to be in academia. And that's how you start to fill up some ranks in in faculty positions. I mean, not by putting them in a program where they maybe don't belong, and then they struggle and struggle and struggle, and that's not going to turn them into faculty members.
So it
So
sounds like, you're taking the position which, 5 seconds ago wouldn't have been controversial, that diversity is good when it's achieved by meritocratic standards, right?
mhm.
Yeah.
Yeah, yeah.
Okay.
I mean, and again, it's not. I mean, it's for their benefit, right? I mean, it's
Yes.
not about that. We're trying to be exclusive or something. It's that we really want them to have a good experience, and putting them there in an environment where they maybe don't have a chance to be successful because of their minority status, that isn't fair to them. And I think ultimately that ends up hurting them, and hurting their chances of actually being successful in academia and maybe faculty members, and actually leading to a more diverse STEM
Yeah.
faculty, and across the country.
And perhaps even that fitting to the right institution might bring them further in terms of just their own personal intellectual inquiry, because they
Yeah,
get the training that they need, right,
exactly. Yeah.
to be able to push their ideas further, rather than sort of putting somebody in a position they're not quite ready to succeed at yet.
Yeah,
um,
exactly.
so online education, I wanted to talk to you about this. My university is rapidly moving towards, the graduate program that I directed for a long time is moving rapidly online, not all at once, but our data science master's degree is also online. What's your take on online education, and is there any reason that statistics couldn't be taught effectively in an online setting?
Um, so yeah, I mean, I guess same as you. I mean, we have a number of online programs, and so we have an online master's degree, and I think we have other things that are like some kind of like certificate programs that are largely online. And so, I mean, this is well, at the moment, these are all like so there's no undergraduate online degree, but there's a master's degree and these certificate programs. So these are all kind of in that window between undergraduate training and PhDs. I think in terms of like teaching courses, the online platform, I think, is can be effective. If I guess it does help for students to have some ways of interacting. I guess if the online course doesn't have ways for the students to interact either with one another or with like the professor, it's kind of hard to see how this is any better than just watching some YouTube videos to learn. But I guess at the end you get the certificate that says you completed some program, and that helps students. I mean, maybe that's what the students really want, anyways, is the degree that says that they have this kind of training. I think that this more or less can be done effectively, and I guess we'll learn to do it better as this becomes more and more common. I guess so. The thing that came up with us recently. This was like in a subset of some faculty members dealing with some talking about whether we wanted to move forward with this. I guess there was a proposal to move towards an online PhD. I guess this I have some, I'm sort of more concerned about this. I do feel like there's a big difference between in the kinds of training for students in a PhD program versus, say, a master's program. Is that master's, the expectation is basically that you can learn existing things and apply them. And basically, I mean, in our context, it basically means that you can implement some of these statistical methods to do some data analyses. In a PhD, you're supposed to be able to create new things. And I think that this feels like, to me, it's like a more immersive type of experience, and that you really have to, A, have to commit to it, and B, really need this like community of people that you're around, that you can talk to and that you can sort of feel a part of. The online PhD program really doesn't, I mean, there's no way it can do that. It can teach them more advanced courses, sure, but that's not what a PhD is about, if you ask me. So a PhD is really about becoming an expert in the topic and being able to create, not just to learn. And I think that that's a whole
design your own research questions.
Right. Yeah, and I mean, I guess in statistics or math, I mean, like a lot of what needs to, part of what's a PhD dissertation is like formulating new ideas and like giving proofs of things that weren't already known before, right? So it's not the so it is creating, right? It's like you have to have ideas and you have to create some kind of like justification for those ideas. It's not different than any other field, but I guess it's more than just learning what's out there and then using what's out there, which is basically what a master's program is intended to do.
Yeah.
So I worry about what will happen in terms of like how do you make sure that you're sort of keeping students on track to actually be experts when if at least portions of the program are designed for them to do it while they're working part-time, and things like this. I mean, obviously there's nothing, I mean, if that's the kind of situation someone's in, that's fine, but I don't know that that's where you can expect the sort of the best, that's what am I trying to say? That the students who are sort of split between I have a job and I'm also doing a PhD, they're not like going to be fully invested in the PhD the way that it's really intended to be, I suppose. And so I worry about that being able to maintain some kind of quality. And it's also weird to me that I guess I worked hard, you worked hard, like, so all of my colleagues, we worked very hard to get PhDs, and this was some substantial commitment in time and energy, and that we're so willing to, sort of make it so easy or like relatively easy for others to get it. This kind of relates to that inferiority complex. I don't know. I feel like we should have this kind of idea that the earning PhD in statistics is something that requires some serious investment of time, and that you can't do it while you're sort of working a job part-time, right? But the idea, I guess, is to try to be more inclusive and to bring in other well, maybe it's about money.
The DEI manifests itself.
Sure.
Is that traditionally the doctoral period, the period of doctoral study, leisurely is kind of the wrong answer, but it should be a time where you are exclusively dedicated to learning what will be your craft. I wonder, does a statistics PhD student or doctoral student, do they teach because in an English graduate or English doctoral degree, this is where most, arguably the part that really cannot be done effectively online is, at a lot of PhD programs in English, the graduate students are teaching the 101 and 102 course, and this is where you learn to teach.
Yeah.
Does something like that happen in statistics?
Yeah. So a number of students, not all of them, but a number of students will teach like the undergrad courses in statistics. When I was a PhD student, I taught um, basically every semester when I was a student, and so I got lots of teaching experience through that. And I mean that was a hugely valuable
How could
experience.
such a thing be approximated online? I mean, I guess you
Yeah,
could
I mean
give them
that
online sections to teach, but that doesn't really teach you anything.
No, I doubt that that would be part of this. I imagine that it would be like focus on here's some courses, and then you try to do your research project, and the teaching aspect would not be really in the equation. But I mean, this is definitely right. I mean, this is partly where I mean, you get some experience being able to talk to people just generally, like public speaking, that kind of stuff. Um, but you also learn your subject better, or like it helps you learn your subject when you have to explain the things to students, right? And you're responsible for them to be able to understand, right? It's this, you need that kind of pressure, and you think about what's the right way to explain things. You have to have some kind of mastery to be able to do that.
I had a professor who used to say, "You don't really know it until you've taught it."
Yeah,
Um,
exactly. No, I mean that's absolutely true. Is that because you can. I mean, I've had this before where I thought, okay, yeah, this is easy. I can go and explain it, and then I get in there and I'm just like I can't just be, and then you realize, okay, I really didn't know what I was getting into, and so then you have a few flops like that, and then you realize, okay, I got to be better prepared.
yeah. Well, there's definitely this watering down of credentials that seems to be happening across higher ed. I mean, um, I don't know about y'all's enrollment, but the general enrollment at my university is down. And we're preparing for continued decline. I think that the inferred probability of the next 10 years in higher ed is that there will be fewer students than there have been over, say, the last 20 years. And I think that part of the reason for that is people are getting hip to the fact that the bachelor's degree is not the golden ticket that it once was. There were, when I was a kid in high school in the mid 90s, there was assumptions, especially against sort of middle class families, that the bachelor's degree was the ticket to the middle class.
Yeah,
And I don't think that that's true anymore. And I think not only is it not true, I think that American families,
it's a
especially
burden.
middle class families, are starting to get hip to it. Um, and and I think that that's why, especially a lot of young men, 18, 19-year-old guys today are just like, you know what, there's other ways to do this.
Mm-hmm. No, I mean, I totally agree with what you're saying. I think that here we've seen some surge in enrollment, but it may not be like sort of uniform across the like just generally across the university. So where I know I've heard about surges is in the engineering. So we have a pretty big engineering school.
Hmm.
So I don't know that this is representative of the. I mean, it's not representative of the university as a whole because many of those students, I mean, that I guess if you have engineering training, right, that sets you up for either graduate programs or other kind of internship opportunity. I mean, so that there is maybe some track there, like that's is still a practically useful track into successful career. But other parts of the university, I would imagine that it's the same kind of thing happening. Obviously, the university's message to us is going to be that the enrollment's up. Maybe it's that everyone's down and engineering is up enough to kind of balance it out. But I mean, it wouldn't surprise me that that's happening really everywhere. There might be some, like I was mentioning, like engineering that's like keeping things at least from the outside looking like it's moving up. But I mean, ultimately, like tuition goes up and all of this because, at least partly because if the enrollment's down, then they have to maintain, and so it's just this sort of
STEM
steady.
fetishism is going to buoy your field, right? Like, I mean, it's still such a hot thing. English departments have been in decline, steady decline for the last 50 years. And rather than change anything that we're doing, the approach seems to be, let's take the things everybody hates us for and do more of it. Um, you know, and and so I'm not real optimistic about the prospects of English departments over the next 20 years, especially since, as far as the DEI stuff, nobody is more resolutely dedicated to that than English departments. And so, routinely we don't get the best, students or faculty for some of the reasons that you described.
Yeah, that's
Um,
too bad. Yeah.
it is. Well, we've been going for a long time, so we should wrap it up. But
Yeah.
we covered a lot of ground, and I feel like I didn't make too much of a fool of myself in
No,
talking
absolutely not.
about
Absolutely not. Yeah.
statistics. And that's really fascinating. Actually, like I think these connections to things like COVID, elections are really a great way, at least to help me understand some of these things. And so, Ryan, thanks very much
Yeah. Thanks, Adam.
for
Yeah,
joining
appreciate it
us.
having a chance to come on.
It's awesome conversation.